It's now time to practice the skills that you've learned. I'm going to go ahead and change this angle measure to something a little bit more difficult. Let's make this angle measure for angle 4 equal to 13 degrees. So we'll start with 13 degrees. Please pause the video. Try to fill in all of these angles on your own, and I want you to use each type of reasoning. So let's use supplementary angles. Once you have used that type of reasoning, don't use it again until you've used all of the others. Then I want you to use vertical angles. I also want you to use alternate interior angles, alternate exterior angles, and let's also use corresponding. Bonus points if you use consecutive interior exterior angles. Those are more rare. I'm teaching you about consecutive interior exterior angles, but they don't really have that on the EOG. Just helpful information. Alright, so hopefully you paused it and you've already completed on your own. Now I'm going to use the reasoning, all of these reasoning, types of reasoning. So I'm going to start with vertical angles, and I'm going to say that angle 2 is equal to angle 4. And then, once again, the picture is off. That doesn't look like 13 degrees. Now from here, what I'm going to do is I'm going to use alternate exterior angles, and I'm going to say angle 7 and angle 2 are alternate exterior. So this is also equal to 13 degrees. Then from here, I'm going to use alternate interior angles. That reasoning, so 4 and 5 are alternate interior angles. They are congruent. Let's go ahead and use consecutive. So I'll use 3 and 5 are consecutive interior angles, and they're supposed to add up to 180 degrees, so this should be 167 degrees. I'm going to use, what do we have left? Let's see. Corresponding angles. Let's see what I have left. Okay, I can use angle 3 and angle 8. Those are corresponding angles. They're both bottom left, so they're both going to equal 167 degrees. And then I also need to do supplementary angles. So I could say that 4 and 1 are supplementary angles, so this is going to be equal to 167 degrees. And the last one I need is angle 6, and I've used all the different types of reasoning, so I'm going to use alternate interior angles. This is also 167 degrees. And you'll see the setup on top, 13, 167, and the setup below is the same. For angle 3 and angle 4, it's 167 and 13, and 8 and 7 is 167 and 13. So you can practice that by giving yourself an angle, one of the angles, and seeing if you can fill in the rest of them, and use all of your angle reasoning so that you can practice your vocabulary. Here's an example of something you might see on the EOG. You are building a bench for a picnic table. The top of the bench will be parallel to the ground. If the measure of angle 1 is 148 degrees, find the measure of angle 2 and the measure of angle 3. So for some reason it's easier for me when I draw just lines instead of having it be an actual bench. So I'm going to show, alright, there's parts of the bench, and I'm going to continue them past. So this right here is represented right here. So hopefully you can understand. Here's the ground, and then this line that's parallel to it is supposed to be the top of the picnic table. So what you'll notice is that we have our set of parallel lines, But this picture is pretty complicated. And what I'm going to do is I'm going to show we have our set of parallel lines, and I'm going to show we have this transversal. And we're going to look at this first. Let me label this according to what the picnic table is labeled. This was L2. This is L3. And then over here, this piece is L1. And let me reread what we're supposed to do. If the measure of angle 1 is 148 degrees, so let's write that in. This is 148 degrees. So if that is 148 degrees, find the measure of angle 2 and the measure of angle 3. So if you just look at the blue pieces, the transversal and the parallel lines that I colored in, you should be able to notice that angle 1 and angle 2 are alternate interiors. So that means that the measure of angle 2 is 148 degrees. And then from there, we're also supposed to figure out what the measure of angle 3 is. And if you think about L2 and L3, how they're related, hopefully you realize that these are supplementary angles and that the measure of angle 3 is 32 degrees. Because 32 degrees plus the 148 degrees, that'll give us 180 degrees. And if you were to explain your answer, you would just talk about what I said, you know, alternate interior angles, you know those are congruent. You know that the measure of angle 2 and the measure of angle 3 are supplementary. Let's go on to the next problem. Example 2. Show that the measure of angle 3, 4, and 5 equal 180 degrees if line L and M are parallel lines and transversal 1 and transversal 2 are transversals, or T1 and T2 are transversals. So once again, it looks more confusing because we have two transversals and we have one set of parallel lines. So let me highlight in blue. Let's look at this transversal T2 and then this parallel line and this parallel line. And let's see what we can notice, if there's anything that we can notice. So we need to prove that 3, 4, and 5 are congruent. So what I'm going to say is this, all right, 4 and 2 are alternate interior angles. So I know that the measure of angle 4 and the measure of angle 2 are equal. So I could say that this could be really angle 4. I could label angle 2 as angle 4 because they're congruent, so they're the same thing. And then what I'm going to do is I'm going to highlight this in red now, and we're going to look at the transversals. I mean, one transversal in the parallel lines, but we're going to look at the other transversal, transversal 1, cutting through those parallel lines. And over here, what you should notice is that angle 1 and angle 5 are corresponding angles. They're both top right, and so those are congruent. So technically, I could say that angle 5 could replace angle 1 because they are congruent. And we know that this whole piece here is equal to 180. So we could say 3, 4, and 5 add up to 180 degrees. And this would also prove that 3, 4, and 5 inside here, in a triangle, you have 180 degrees. So let's make sure that we answer the question. Show that measure of angle 3, 4, and 5 equals 180 if blah, blah, blah. Yeah, so we did that. Let's go ahead and go on to the next problem. Example 3. If the figure below, line X is parallel to line YZ, prove that the sum of the angles of a triangle is 180 degrees. Alright, so we have line X is parallel to YZ. And let's show that using this transversal, 80 degrees and C degrees, those two measurements are equivalent because of alternate interior angles. So we know that C equals 80 degrees. In addition, we could look at our other transversal. Here's our parallel lines, and then our other transversal. We could see that 35 and angle A are congruent, so the degree measure of angle A is 35 degrees. And then we know that if we take A, B, and C, A plus B plus C, that equals 180 degrees. So we know that the measure of angle B must be 65 because 35 plus 65 plus 80 gives us 180 degrees. And then since that's true, we just proved that the measure of angle B should be 65. So we know that when you take the 65, the 80, and the 35, it equals 180. So we know that a triangle has to be made up of 180 degrees. And the next problem, example 4, what is the measure of angle 5 if the measure of angle 2 is 45 degrees? So the measure of angle 2 is 45 degrees, and the measure of angle 3 is 60 degrees. Alright, so let's look at this transversal and these two parallel lines, and we keep using this information that alternate interior angles are congruent. So 2 and 4 are congruent, so that means that angle 4 is equal to 45 degrees. If you take 60 and you add the 45 degrees, you're going to get 105 degrees, which means that you're left with 75 degrees for angle 5. So the measure of angle 5 is 75 degrees. And if you want to check that, just add 75 plus 45 plus 60, and you'll see that you get 180 degrees. So angle 5 is equal to 75 degrees. And I believe that's the last example. So hopefully you have a better idea of how to use your information about angles when you have two lines that are parallel and a transversal cutting through them.